The question says that give the magnitude, direction and net force acting on a stone of mass 0.1 kilogram just after it is dropped from window of a stationary train. And the second question is just after it is dropped from a window of a running train at a constant velocity. And the third is just after it is dropped from window of a train accelerating with 1 meter per second square. And the fourth is lying on the floor of a train which is accelerating with 1 meter per second square, the stone being at rest relative to the train. We have to neglect air resistance throughout. So let us draw some diagrams that will explain the question a bit. So in case A, let us assume that this is the train and this is the reference of ground. So the train is stationary, that is V equals to 0, and the stone is dropped. So we have to find out magnitude and direction of the net force acting on the stone. So this stone was stationary, and we all know that gravitational force is acting whichever body has mass. So the only force present here is the acceleration due to gravity or the gravitational force. So force would be equal to mass times acceleration, and that would be 0.1 kg multiplied by 10 meter per second square, that is 1 Newton, downward direction. Now in case B, we have just after it is dropped from the window of a train running at constant velocity of 36 km per hour. So in this case we have this train, it has a velocity of 36 km per hour. Let us assume that the velocity is in this direction. Now we see that the velocity is constant. Also, when the stone gets detached from the moving object, that is the train, then it has got nothing to push. So the constant velocity represents no acceleration in this direction, and the only acceleration that is being acted upon is the force of gravity, because it is under free fall. So just like before, its force would be force equals to mass times acceleration, which is in downward direction, that is acceleration due to gravity, and that would be equal to 1 Newton. Now in third case we have just after it is dropped from a window of a train accelerating with 1 meter per second square. Now this time we have got acceleration of the train, and the stone is thrown. So as soon as the body gets detached from the train, its acceleration is gone. So the case when the stone is thrown out of the window, then again only one force is acting on the stone, that is the force of gravity, and again the magnitude is equals to force equals to mass into acceleration, that would give us 1 Newton. Because as soon as it gets detached from the train, the acceleration is lost, thereby there is no any force because there is no any acceleration. So the only force that is present after it is thrown is due to gravity, and that is 1 Newton. Now in fourth case we have lying on the floor of the train which is accelerating with 1 meter per second square, the stone being at rest relative to the train. Now this is a case where stone is here. Let us assume that the stone is here sitting idly, and the train is accelerating with 1 meter per second square acceleration. Now here we see that as the stone is at rest on the floor of the train, so even though the force of gravity is acting in the downward direction, also there is a reaction force that is acting in the upward direction, that is keeping the stone at rest, and that is equal of the magnitude and opposite of the direction of the force of gravity. So these two forces cancel out this time. Since the train has got a net acceleration of 1 meter per second square in the moving direction, so the only force that would be acting is mass times acceleration in the direction of motion, and that would be equal to 0.1 kilogram multiplied by, what is the acceleration? 1 meter per second square. 0.1 kg multiplied by 1 meter per second square, and that would give us 0.1 Newton. Thank you.